Hello, everyone, and welcome. Today we'll be exploring the relationship between carbon dioxide emissions and panic attack prevalence. My question is, can pollution, specifically airborne carbon dioxide emissions, contribute to panic attack prevalence? Now, why did I choose these two specifics? Well, according to the US Energy Information Administration, as of 2019, carbon dioxide makes up 81% of airborne pollutants, being the most common airborne pollutant we have. And when it comes to panic attacks, researcher Joe Hemmings says in How Psychology Works that panic attacks affect 10% of US residents, in a five-fold prevalence over panic disorder. She goes on to explain that this may be caused by carbon dioxide. So, what do the experts say about this? Well, Gorman and colleagues say in 2004 that they noticed that carbon dioxide treatment resolves cognitive symptoms of panic attacks, but they noticed that it's not the only contributor, so that leads them to believe that the other factor is likely neurological. After that, Lopez and colleagues find a list of symptoms of panic attacks caused neurologically by carbon dioxide. In addition, Roberson and others find a positive linear association between carbon dioxide levels and panic attack symptoms. When it comes to things that aren't neurology, Lehman and colleagues lead the way by finding a negative relationship between alcohol consumption and cognitive panic attack symptoms. Meanwhile, Levitt and others see that emotional environment has little to no effect on its panic attack mechanism, and Van Beek and others find that respiratory disease likewise has little or nothing to do with its mechanism. So from these previous research that we use, the mechanism is most likely neurological, which can help us narrow down panic attack treatments. The reason that these findings focus on the mechanism of carbon dioxide is because little to no research before this has tackled the actual question of how pollution impacts panic attacks. So what can we infer from this? From the studies of Lopez and colleagues in 2010 and of Roberson and others in 2017, we can infer that physical symptoms are the best way to track panic attacks. Lopez explains the myriad of neurological symptoms, and Roberson and others address the physical symptoms as the most trustworthy and the ones that we should treat first. In 2002, Lehman and colleagues report an inverse relationship between alcohol consumption and cognitive panic symptoms, suggesting a chemical solution. If the solution is chemical, then it's likely that the cause is the same, which pollutant carbon dioxide would fit well in the realm of. So for this study, I plan to conduct a linear regression analysis through a dependent t-test. The data will stretch across all 50 states and span over the years 2014 through 2017, when data is available. The US Energy Information Administration will provide data over the years 2014 through 2017 for state-level carbon dioxide emissions. Combined, the National Institute of Health providing national panic attack rates and the Substance Abuse and Mental Health Service Administration displaying mental illness rates per state will give me data in the form of an estimate ratio. This limits the study because it's not the most accurate, but this ratio is the best I can do with available data. I will use Excel to contain the data and form the association check and Tableau Public to display graphs. As it turns out, carbon dioxide has a close but complex relationship with panic attack prevalence at the state level. Though the overall association is weak and inverse and therefore not significant, 37 states, nearly 2/3, show significant relationships. Of these, 23 are negative and 15 are positive. Though the overall relationship and the proportion of panic attacks explained by carbon dioxide emissions is fairly small, the significant relationships at the state level cannot be ignored. This leads me to believe that there is a third variable at play. Which leads to the question, what is this third variable like? Well, it has a few criteria. It must affect both CO2 and panic attack prevalence, and it must vary by state. Examples fitting this mold include levels of industry in the states, which political parties the states hold, which kind of weather the states have, and what population density each state experiences. To sum up, carbon dioxide emissions and panic attack prevalence are related, but not how we'd first imagined. A third variable likely plays a role due to the number of states that have significant relationships, even though the overall nation doesn't. And I will run future association checks to find out which variable it could be. Limitations of this study include the estimate ratio that I had to perform, the restriction of range with the years performed in the study, and the fact that we can't account for the county level because there's not enough data for that county level. Thank you for listening.
Excellent. Thank you so much, Kylie. Let's see. I think Monica, you were next on our list.
Everyone, thank you for being here today to listen to my research, and also thank you for staying safe. My name is Monica Muller, and I'm here to talk to you about the effect of mistrammel distance on capture frequency and entanglement of birds. Now, some of you may be wondering, what is a misnet? Well, a misnet is a finely meshed net that is stretched between two poles, and its purpose is commonly used to capture flying birds and bats for scientific research purposes. Typically, misnets are structured in a way where there are 5 horizontal trammel lines, and in between these trammels, there are seem to be 4 stacked pockets total within the misnet, and these pockets is where birds and bats tend to become captured in. The distance between the trammels affects how deep the pockets are. So if the pockets are closer, or the trammels are closer together, it makes a deeper pocket. And if they're further apart, it makes a shallower pocket. Now, the purpose of my experiment was to determine, or try to answer the question, how does the distance between trammels affect how many birds are captured, and how often do they become severely entangled? Now, from the very beginning, I saw many possibilities with how this could turn out. With near-spaced trammels that have deep pockets, since the trammels would be closer together, there would be less surface area covered by the net, which could result in less birds being captured. But with deeper pockets, this would maybe result in more birds being captured. The problem with deep pockets, though, is that since the pockets are deeper and therefore closer together, birds could become more easily entangled. With far-spaced trammels that have shallower pockets, since the trammels are further apart from each other, it increases the overall surface area of the net, which could possibly increase the capture rate. But with shallower pockets, it's more likely that the birds will bounce out, which could decrease the capture rate. But on the bright side, with shallower pockets, there's a possibility of less severe entanglement since the pockets are further away from each other. And with bird banding, what we want to do is we want to try to find some way that we can increase the capture rate so we can gather more data on the populations of birds in the area, while at the same time minimizing how many severe entanglements there are. Because when a bird becomes severely entangled, it can be very harmful and stressful for the bird, and we want to avoid that as much as possible. So for my experiment, it took place at the Lewisville Lake Environmental Learning Area, most commonly known as LELA. Now, LELA is an area that consists of eastern frost timbers, bottomland hardwood forests, blackland prairies, wetlands, ponds, and the Elm Fork of the Trinity River. Now, the mission of people who work and volunteer at LELA is to preserve and restore native Texas ecosystems and biodiversity, while also providing opportunities for education, research, such as my experiment, and recreation. LELA is managed by a staff that oversees volunteers and the preserve and takes care of it. Now, my experiment took place from the 17th of April, 2018 to the 22nd of May, 2018. And data was recorded from about 19 days in this time range, from 20 nets. The experimental treatments for the nets were near spacing, which is where the trammels are spaced 35.6 centimeters apart from each other, and far spacing, where the trammels are spaced 45.7 centimeters apart from each other, so about a 10 centimeter difference. Now, the trammel spacings for 10 random nets was set to be near space, and for the other 10 random nets, it was set to be far spaced. Now, to avoid measuring the trammel spacing every single time we open the net, I measured where the spacing with the trammel should be placed, and in those areas on the poles, I put different colored tape so that we can know where to put the trammels, like from the very beginning of the day when we're opening the net. I used yellow tape to indicate where the near spacing should be, and orange tape to indicate where far spacing should be. And in terms of the lowest trammel, it was typically placed around 38 centimeters above the ground, because we don't want it too close to the ground, because then if a bird gets captured, it can get stuck like on the ground and like go into the leaves, and it can be kind of dangerous. But if it's too high, there's too much space underneath the trammel and birds can go fly right under it. The experimental treatments that were applied to the nets was switched on consecutive sampling days. So on one day when the net was near spaced, the next day it would be far spaced and vice versa. The volunteer bird banders at Leela and I, we recorded the amount of captures and severe entanglement. What we did was, with the help of volunteers there, we checked the mist nets every morning at approximately 30-minute intervals so that we could collect the captured birds and also record what specific net they were caught in. And birds were considered to be severely entangled if they were in multiple pockets at the same time, which we call double or triple bags, or if they were twisted into the net. Now, after my experiment was finished and I just looked through all the data, I noticed that in terms of capture frequency, for the near space net, within a 10-hour period, on average, we caught 1.423 birds with a standard deviation of 1.270 birds. For the far space net, within a 10-hour period, on average, we caught a little bit more, about 1.571 birds with a standard deviation of 1.106. I did a t-test to see if there was any relationship between trammel spacing and capture frequency. And with a p-value of -0.38, and especially the p-value of 0.46, that indicates that there's no relationship between trammel spacing and capture frequency. Next, for severe entanglement frequency. For the near space nets within a 10-hour period, typically birds got severely entangled on average about at like 0.121 with a standard deviation of 0.203 entanglements. And for the far space nets within a 10-hour period, on average, there were 0.107 severe entanglements with a standard deviation of 0.178. So a little bit less, but when I did a t-test to see if it was significant, with a t-value of 0.23 and a p-value of 0.84, we also thought that it was not a significant difference. So there's no relationship that we can see, at least, between trammel spacing and severe entanglement frequency. Now, when I first began this experiment, I wasn't expecting to look at anything more than just capture frequency and severe entanglement frequency. That's all I was really interested in. But once I looked at all the data, I noticed that with certain species, there was more of a difference in how often they were caught in certain nets, specifically with indigo buntings and Swainson's thrushes. Indigo buntings were most often caught in the near space nets, with a total of 11 being caught in near space nets and only 3 being caught in far space nets. For the Swainson's thrushes, however, it was the opposite. They were most often caught in the far space nets. We caught a total of 24 Swainson's thrushes in the far space nets, with 17 in the near space nets. So it is a lot of birds that were caught overall within each type of net, but that is still kind of a significant difference compared to the other species. So I did a chi-square test to see, is this significant? Would these typically be caught at the same frequency in the different types of spacing, or should it be different? Like, is it expected or is it significant? And it turns out to be significant. The chi-square value was 5.743, and the p-value was 0.02. So this actually is really interesting right there, because it's unlikely that they would be caught in the same kinds of spacing. So when looking through mostly the p-values, I saw that for 2 of them, they were not significant, and for 1 of them it was. So I basically judged the p-values on, like, if they were less than 0.05, then they were sorry, I have trouble saying that word, statistically significant. The differences are quite pronounced. So between trammel spacing and capture frequency with a p-value of 0.46, no relationship between trammel spacing and capture frequency, as far as we can tell. Between trammel spacing and severe entanglement frequency was 0.84, so also no relationship between trammel spacing and severe entanglement. But when it came to species patterns, for the capture totals between indigo buntings and Swainson's thrushes, there was a p-value of 0.02, less than 0.05. So this means that it's unlikely that both species would be caught at the same frequencies in both types of spacing. Now, the implications of my research is that, in terms of spacing at least, trammel spacing of 36 centimeters to 46 centimeters, which is common for most mist netting operations, is appropriate for the capture of birds by researchers. If it was less than 36 centimeters, then this could cause significant problems in terms of capture rate and severe entanglement. it would probably reduce capture rate because the net would be significantly smaller than it should be. And the pockets would be way too deep and there'd be too much overlap, so they'd probably come severely entangled far more often. And if it was more than 46 centimeters apart, they probably wouldn't even be caught, because even though the net would be much larger and have a bigger surface area, there'd be almost no pockets left. It'd be so shallow that the birds probably just bounce right out of it. Although on the bright side, there would be less severe entanglements because of that. So basically, my research says that for 36 centimeters to 46 centimeters of trimal spacing, it's good. It works, and it should probably stay that way. Now, for species patterns, we saw that some species were caught more frequently in certain spacings than others. Specifically, the indigo buntings were caught more frequently in near space nets, and swings and thrushes were caught more frequently in the far space nets. And what this tells me is that we should probably do additional research with larger sample sizes to see if we can kind of explain more about these species patterns and maybe find out some other ones that we don't even know about yet. And now I'd like to say thank you to some organizations and people. This research was a lot. I am an undergrad. I don't have much experience doing research, and so many people and these organizations were a big help to me, and I'm so glad that they exist and they do what they do. Otherwise, I wouldn't have been able to do any of this. So I would like to thank the UNT Office of the Provost, the UNT Office of Research and Economic Development, UNT Honors College, the UNT College of Science, UNT Department of Biological Sciences, and the people who worked very closely and personally with me, Dr. James Bednars, Dr. Kenneth Steigman, the Leela Bird Banders, and Texas Master Naturalists. This was a great opportunity. I'm so happy I did this, and thank you all for being here and listening to me.
Excellent. Thank you so much, Monica.
So, good afternoon, everyone. My name is Drew Porter, and today I'll be presenting some research I completed last summer under the mentorship of Dr. Bednars concerning the use of radio telemetry to track the locations and movement of male painted buntings. So painted buntings are migratory passerines. They're a sexually dichromatic species that is native to North America. They're very popular, probably due to the striking, vibrant plumage of the adult male painted buntings. You can see an adult male painted bunting on the left here, and this is what we deem to be a female painted bunting on the right. So currently the IUCN has the painted bunting listed as a species of least concern, but they, like many other songbird species, are facing the threat of habitat loss and degradation due to increasing urbanization and climate warming. Painted bunting populations have been in decline over the past 35 years, and though they are protected under the United States Migratory Bird Treaty Act of 1918, they're still trapped and sold illegally here, as well as in Mexico and Central America. There are two distinct populations of painted buntings. There's the Western population, which my study concerned, which breeds in the South Central United States and Northern Mexico. And there's also the Eastern population, which breeds along the Atlantic coast in the Carolinas and Northern Florida and parts of Georgia. They are migratory birds, as I previously mentioned, so they do travel south for winter, and they reside in parts of Mexico, Central America, Cuba, South Florida, and the Bahamas. So something interesting about painted buntings is that they exhibit the phenomenon of delayed plumage maturation, or in the case of the painted bunting, the subadult males or second year males exhibit a plumage that is similar to the female painted bunting plumage until after their first breeding season. This is not a unique phenomenon to painted buntings. It's been observed in both male and female sexes of other large-bodied bird species, as well as other species of North American migratory songbirds, as well as tropical species of migratory songbirds. You can see here in the photo that the plumage is similar, but we could tell that this is a male on the left here because of the blue developing on the face here. Females will not develop a blue plumage like that, but without an identifying mark like that, or something like a brood patch on a female bunting or in a protruding cloaca, it's very difficult to determine the difference in the sexes, even for experienced ornithologists. Delayed plumage maturation is not entirely well understood or explained. According to a paper published by Hawkins et al. In 2012, hypotheses that seek to explain delayed plumage maturation can be separated into two general categories. There's a molt constraint hypothesis group, wherein delayed plumage maturation is a non-adaptive trait driven by physiological limitations to produce adult coloration. And there's also the delayed investment hypothesis group, wherein subadult delayed plumage maturation is an adaptive life history strategy for which subadult males receive a benefit by delaying reproductive investment. So the female mimicry hypothesis is an earlier hypothesis put forth by Rauer et al. In 1980, and it would be encompassed under Hawkins' delayed investment hypothesis group. Rauer posits that young males with female-like plumage benefit by deceiving older males, which allows them to explore defended habitat and possibly allows them breeding opportunities. In recent years, radio transmitter tag technology has progressed to the point to where we can attach transmitting tags onto small songbirds. And by taking advantage of this technology, it's now possible to track these birds more accurately using radio telemetry and test aspects of these ideas. So based on the female mimicry hypothesis, I hypothesized that after second year male painted buntings, or the colorful males, would have smaller, more well-defined territories in comparison to the second year males with subadult plumage, as well as the second year male painted buntings having more widespread movements in search of future territories and potentially females for extra pair copulations. So my study took place at the Lewisville Lake Environmental Learning Area as well, and I think Monica did a great job with an overview of what LELA is, but you'll hear a little bit more from me. So LELA is made up of over 800 hectares of protected environmental land in Lewisville, Texas, where the Blackland Prairies and Eastern Cross Timbers connect. LELA is also home to the LELA Bird Banding Station, which is, I'm sure, where Monica's work took place. The station was established in 2006, and it's operated by the University of North Texas Institute of Applied Sciences to monitor the movement of spring and fall migrant birds. On the satellite image here, I have displayed two grids where our research was conducted for the Painted Bunting project. On the left, I have Barnow Ridge, and on the right is the Bison Range. Other parts of the Painted Bunting project took place on these grids. However, all my trapping for my project took place off-grid. Initially, we started trapping here north of the Bison Range. However, as the season progressed, we noticed on our way to the study area every day that about 30 minutes before sunrise, a large amount of painted buntings would congregate on this gravel road. This is called Fish Hatchery Road. Especially among this portion of the road right here, we noticed they were congregating in the morning. So we devised a methodology where we would set up mist nets, like Monica talked about, either 6 meters or 12 meters in length, running parallel on either side of Fish Hatchery Road here, overlapping each other. We'd set these nets up the night before an attempted trapping attempt, and the next morning we would arrive about an hour before sunrise, and we would open up the nets, and then we would retreat from the nets and wait until about 15 to 20 minutes before sunrise, at which point we would drive down the road in our truck at very slow speeds with the lights on in an attempt to flush the birds off the road into the mist nets, and trapping this way proved to be very effective. When trapping more traditionally north of the Bison Range or north of Barnow Ridge, we trapped birds in mist nets 6 meters in length with a 30 millimeter mesh size. And what we would do is we would cut into the vegetation along the tree line and place a mist net perpendicular to the tree line in an area where we had previously observed a male painted bunting. We then placed this model bird, who we called Oscar, on one side of the mist net, and a Bluetooth speaker with a painted bunting song playback on the other side in an attempt to lure birds into the nets. During trapping attempts, researchers remained within 30 meters and visually monitored the nets at all times. All birds were immediately extracted when they were captured in the net. For processing the birds, they were immediately processed, only ever in the presence of a permitted bird bander and at least one assistant. We recorded morphological data, measured and recorded morphological data, and banded the birds with uniquely numbered silver USGS bird banding tags, as well as a unique 3-color combination of lake bands in order to identify the birds from afar with binoculars or a scope. After that was accomplished, applicable birds were fitted with nanotag transmitters. These coded nanotag transmitters were purchased from low-tech wireless, and they weighed about 0.48 grams each. With a harness attached, they averaged about 0.5 grams. And so we only selected male birds that weighed 15.2 grams or more. This weight was determined in order to ensure that the transmitters didn't exceed about 3% of the bird's body weight. The literature for similar studies suggests a maximum transmitter weight of no more than 5% of a bird's body weight in order to avoid negatively affecting the individual's fitness. However, we used a substantially more conservative number. In total, we deployed 13 radio transmitters. Leg loop harnesses were constructed using elastic thread based on previous literature from similar studies. The elastic thread was used because the harness has to stretch around the back of the bird when looping around the legs, and it needs to provide the bird with enough flexibility to not negatively affect their fitness. Initially, the harnesses were constructed to have a collapsed diameter of 20 to 21 millimeters. You can see Maria's photo here, how we measured the diameter, and she, in a year previous to me, had good success with that measurement of 20 to 21 millimeters. Unfortunately, I did not have the same success, and at least seven of my 13 deployed transmitters became prematurely detached from the birds. You can see here that the leg loop harness is still intact. This is one of the 5 transmitters that I was able to recover. All the harnesses that I did recover were still intact. So using that information, I began crafting the harnesses with a smaller collapse diameter of 19 millimeters later in the season. I didn't have many opportunities to deploy those transmitters with a smaller diameter onto birds, but the ones that I did seem to be more successful than the 20 to 21 millimeter diameters. So I tracked the birds on foot using radio telemetry. I used a handheld Yagi antenna attached to a low-tech radio receiver, also developed by low-tech wireless. I was able to adjust the direction that I was pointing the Yagi antenna in to hone in on a bird's location. As I got closer to a bird, the signal strength would increase on the receiver, and I could then lower the gain and get more accurately in the bird's location. When I was close enough, I was able to visually or orally confirm the presence of a bird. And after getting as close as I could, I would record that location using a Garmin handheld GPS unit. I would record other information such as the ID of the bird, as well as the time, date, and signal strength. So in addition to the ground tracking, there's a MODIS tower located at Leela atop the dam, and the MODIS tower records radio transmitter locations every 33 seconds. Now, I can't triangulate the position of a bird, and it can't get an accurate location, but it can be used to tell if the bird or the transmitter is either present or absent from the MODIS tower's range. And using that data, I could estimate the date that a radio transmitter fell off of a bird, because there are 3 antennas at Leela, and I could see if the location of a transmitter had been static based on the signal strength and which antenna was receiving the signal. And I could then go through that data, estimate a date at which the transmitter became detached, and then discard any data points that I had recorded from after that date. So ground tracking resulted in 29 usable locations for adult male buntings and 18 usable locations for subadult male buntings. And the mean number of days detected by the MODIS tower was 10.8 for adult and 4.3 days for subadult painted buntings. The mean estimated territory size was 0.192 hectares for adult males and 0.189 hectares for subadult males. So those are pretty comparable. I created this figure using ArcMap GIS software, and I use the minimum bounding geometry tool in ArcMap, which just creates a polygon for the bounding location points. So it's a rough estimate of the location size. It's not a very accurate way of determining territory size. For one individual, I was able to create a kernel density estimate. That was individual after second year 17, so that's an adult male. I use methods described by Locher and Lindenberg in addition to ArcGIS software and geospatial modeling environment, as well as RStudio. I created this home range estimate using 17 recorded data points, which is 2 more than the suggested 15 minimum points required. That was suggested by Anich et al. In a 2009 study on passerine songbirds. And I've displayed these figures side by side so you can see the difference in the minimum bounding home range that I created using ArcGIS and the kernel density estimate. You can see that the minimum bounding area was 0.454 hectares, and the 95% use contour, meaning that 95% of these points these points made up 95% of the bird's range. That area is 1.384 hectares. So there's a big discrepancy there, and we believe that the kernel density estimate is a more accurate way of determining territory size. So in conclusion, my hypothesis was not supported by my results. However, I was not able to collect sufficient location data to draw concrete conclusions. The territory sizes were comparable. However, those territory sizes were a rough estimate based on insufficient data. Kernel density estimates for all the birds should be constructed, but it requires having more data points for the birds. That would allow a better comparison across age classes of home range and territory size. Based on my field experience, subadult males did prove to be more cryptic than adult males. They were harder to target and trap, and after fitting with transmitters, they were detected for a lower mean number of days by the MODIS tower, suggesting that they could have moved out of range. Refinement of the harness design and attachment technique could result in more data collection, as the main hurdle I ran into was premature detachment of the radio transmitters. Hallworth et al. Suggests an attachment technique in the literature. Their technique is similar to ours, but it involves tying the harnesses in the field instead of tying them beforehand. Their technique would allow for a more individual tailoring of leg loop harness size that could result in a tighter fit. However, it would increase the handling time of the individuals, which is something we tried to minimize to avoid stressing the birds. However, an experienced handler could probably use their technique to great effect. So finally, I would like to acknowledge that this work was supported by a seed grant from the Advanced Environmental Research Institute at the University of North Texas, as well as an undergraduate research fellowship from the University of North Texas Honors College. The Friends of Leela and the Prairie and Timbers Audubon Society provided financial assistance in purchasing radio transmitters and receiver. I'd also like to thank the rest of the 2019 Paint and Bunting project team, as well as Ken and Richard at Leela and Maria Rubiano. Thank you.
All right, excellent. Thank you, Drew. Okay, so at this point, I'd like to get a round of virtual applause for all of our presenters today. So terrific work. I learned all about environmental carbon dioxide poisoning and panic attacks to birds. So yeah, at this point, we will go ahead and open it up to questions. I know there's only a few people in attendance that aren't presenters, so I also encourage our presenters to ask each other any questions that they might have about each other's research. So go ahead, if you have a question, you can either raise your hand and we'll go ahead and unmute you, or we can, if you want to put it in the chat, we can go that route as well. All right, Drew.
Kylie and Monica, I just want to say I thought you guys both did a great job. And Kylie, I was wondering if you could speculate on the possible third variable you mentioned, what you might think that could be.
Hear me. Gotcha.
Thank you. I was going to say I have actually done an expansion on this research that I'm not able to present because I haven't done all of the expansions, but I did find some rather interesting results for weather by state. And it turns out that fall weather seems to be a very likely variable for more than 30 states for being that third variable. And weather impacted 40 out of 50 states generally as being the most likely variable. So my money is on weather so far.
Excellent.
Thank you.
Yeah, have you, going off of that, have you looked into like the concept of like seasonal affectiveness disorder, the SADS? I know that is a well-documented phenomenon, you know, when weather changes and people aren't getting as much, I guess it's vitamin B, it's a vitamin B deficiency.
Yes, I've certainly looked into that by targeting winter temperatures and precipitation. Winter temperatures tend to be affecting only 3 states as the most likely variable. Those are mainly southern states where we're not as used to winter weather. And precipitation affects about 10 or 11 states as most likely variable. So it certainly does play a role, but not as much as the fall weather.
Okay. Yeah, and I guess one area where I would ask a question about would be, you know, thinking of ways that you can account for population changes, right? Because as we know, human beings aren't static, right? We don't just stay in one state. So, you know, what would it be like for somebody from a southernmost state moving up to a Midwestern state that experiences weather on a great degree? That might be a future implication for your research as well.
Yes, absolutely. I'd be able to measure that more when I apply the population density expansion. So it'll be much easier to measure when I add that expansion.
Excellent. No, good work.
Thank you for your question. Thank you.
Hi, also Kylie, great job on your presentation. Something I was wondering about with the other possible variables you mentioned, such as industrial and agriculture, political party, that kind of stuff, is what are the trends you tend to notice there, maybe with carbon dioxide emissions and panic attacks? And of course, we know correlation does not equal causation, but do you think there might be some causation there, or that they play a part somehow?
Yes, that's a great question. I'm aware that correlation does not equal causation, but hopefully this existing data research will lead to other researchers maybe doing experiments with this. Can you repeat the second part of your question one more time?
I'm mostly kind of wondering, the main thing is between these other possible variables, like political parties and industrial agriculture, I can kind of go from my experience and from what I know about these topics to kind of guess maybe what the trends would be and why that could be the case. But what's your opinion on that, or what's your perspective?
Okay. So that's a great question. My opinion on that is that definitely the industrial, more conservative states would probably have bigger problems with carbon dioxide pollution and possibly a higher panic attack rates. But I do know from my experience in conservative states that in conservative states, any mental illness can go underreported. So I'm not exactly sure how to predict that, but generally I predict higher areas in both variables with conservative and industrial areas. Thank you.
Any other questions for, oh, okay. All right, Drew, we got.
Cool. And Monica, I don't know if you'd be able to prove this or anything, but I was wondering what your opinion is. I know when the trammel distance is more narrow, which causes a more bunched up pocket, I think that the net might become slightly more visible because it creates a more distinct outline because of the bunching. And I was wondering if you thought that that could affect the capture rate of birds because the birds might be able to see the net more clearly.
That's actually a really good question. Thank you. So I know that's something that we I was aware when I did bird banding at Lila that we want to make sure that the birds are not going to see the net because they would try to avoid it in that situation. I would think that if the trammels are closer together and there was more like bunched up netting and like pockets are more overlapped, it probably would be more visible. I don't know how much more visible it would be to birds if there was just like standing like on a branch nearby and they saw it standing still. That's the one thing. If they're flying, and I don't know if they would be able to notice it more like in that very split-second moment. I would think there might be a lower capture rate if it's like a smaller trammel distance because it would be more bunched up and more visible. But definitely there could be more research done about that. I think that'd be really interesting to look at. But then there's other things to consider, kind of like would the lower capture rate be because of increased visibility or because of the lower surface area and stuff like that? So I'm not sure how exactly people would go about researching that, but I would love if people would research that and so I could learn more about it.
Any follow-up questions?
I have a question for Drew.
Yeah.
Also love to research too, especially because, birds.
Mm-hmm.
In terms of if you were to go back in time and redo certain aspects of the experiment, I know you had some trouble with the I think it was called harnesses, staying on the bird, it was going off. I'm what were some changes you make to the experiment and how would specifically what kind of changes? So I think with the harnesses maybe you would make some, but are there any other things you would have changed?
Yeah, definitely. In a perfect world, I would have a lot more time to work with the birds, but the season is so short, and being an undergraduate, I don't have multiple years to pursue the same project over and over and over again. So I think with more time, I would be able to tie the harnesses in the field and attach them depending on the bird, like I said in the paper, which would have that more tailored fit, and I think that would result in a better retention rate. Other papers discussed using heat shrink tubing to attach radio transmitters to tail feathers. There was also some talk about super gluing transmitters to the birds, but as you know, the first priority when working with live organisms is to not negatively affect their fitness, and so any method that we use has to be scrutinized to determine, is this number one going to leave the bird able to survive, and then number two, give us the data that we need. Thanks for your question.
All right. Kylie, what's going on?
Sure thing. One thing I was wondering with Drew, I am not an environmental sciences major, so both of your presentations, Monica and Drew, were very informative, not an area I'm familiar with. So Drew, I was wondering if you could tell me, if you could further explain radio telemetry. That's something I'm very unfamiliar with.
Sure, yeah, definitely. Radio telemetry is basically just using transmitters to send out radio waves and receivers to collect geographic data. It's been used, since the 1800s. I think the first ones were. In ecology, it's been used since about the 1950s, with the size of the radio transmitters always being kind of the limiting factor on what organisms you can use it in. It's used a lot in marine environments, on large marine animals, and there it acts kind of like sonar because it's in the water medium. The signals can be transferred that way. In the 90s and early 2000s, it could be used on large birds like waterfowl and stuff. They can have radio transmitters put on their, I guess they're little ankles. They're not called ankles, but like that. More recently, though, technology keeps getting better and better. Transmitters keep getting smaller and smaller, and finally, they are light enough to attach to songbirds, which is really exciting because people have had these questions for a long time, and now there's the ability to collect some data. However, size still is a limiting factor. Birds are very lightweight. They have hollow bones. They're aerodynamic so that they can fly. So we had to release a lot of birds without putting transmitters on because they didn't meet that 15.2 gram cutoff. So I hope that answered your question.
All right. Any other questions from? Well, I do have a few comments. So to start, Kylie, I think that your research is really interesting, and kind of going back to that idea of correlation doesn't necessarily mean causation. We've heard that many times, but what I think that correlation can do is it gives you an opportunity to point your finger somewhere and say, hey, there's something over there that we should be looking at, whether that is a causal relationship or maybe what you've maybe identified, which is maybe more of a mediating or moderating relationship, that there's some other variable over there that's connected to CO2 rates and connected to, instances of panic attacks. There's something there. So it kind of gives you a direction to at least point your focus at this point. So really interesting question. Do you know Joey Toth?
No, sir, I don't.
Okay, he's another honors college student. He actually looked at issues of mental health and the amount of sunlight that a state receives. And so his thesis was about looking at the correlation between sunlight and mental health. And so he did a really good job in his study that he kind of broke down a bunch of the different other maybe covariates, the things that can influence his variable of interest, right? His dependent variable. His thesis is available on the North Texas Undergraduate Research Journal, or the Eagle Feather, what it's called now. And so I think that might be a really good research design to look into because it follows very similar parameters to what you're looking to do with your research as well. So, but again, I think really good question. And just maybe one other thing to think about is, since you're dealing with multiple years of data, you're looking at 2014 to 2017. You can approach it as just one big data set like you did. You could also do it as a panel analysis, so looking at each year independent of one another. And if you decide to go down that route, you can get a lot of statistical power that way by kind of grouping your standard errors. And so something to think about as you approach further on. Are you going to be working on this as a thesis project at this point?
No, sir, it was just an idea I came up with in my 1500 class last semester.
Okay, cool. No, it's a very good idea. So if you decide to continue on with this research, I think that there's some real practical ways that you can kind of begin making some inferences between these connections. So, so good work. Now, for Monica and Drew, I am not an environmental science person either, but I think that your work is really valuable and important. One of the things that I know has been particularly with tracking birds and tracking migratory populations, the importance that it has with epidemiology. I'm sure you're both aware that birds carry diseases such as avian flu and all sorts of other things. So kind of learning a little bit more about how researchers such as yourselves go into the field, trap these birds, are able to put mechanisms on them to track them, has been very interesting. I guess some of the things that, like some of the notes that I had, were more about, what are your plans after doing these research projects? Are you going to be continuing with this type of research? Is graduate school something that's in your future? Monica, I'll have you go first.
Thank you. Well, definitely something I've always been interested in, and I would love to spend more time with is just animals in general. I love birds, but not just birds, like all animals. I want to just like be very hands-on and like maybe conservation, maybe just like monitoring them to make sure like because typically the health of an animal can be used to help in an environment, so like population size and everything. So I would love to like do more with maybe bird banding or just other kinds of animals as well. So in terms of like a career path, this might actually be something I would like to continue with. In terms of graduate school research, I probably would like to do that as well. Like I'm not planning to go to graduate school right after I get my bachelor's. I want like a little bit of a break in between. But definitely once I do try to get my master's degree, I would love to maybe do more with either bird banding and trying to go more in depth and learn way more about them, or maybe kind of switch to something similar but still different. So definitely this is something I can see myself doing in the long term, like things with like animals and even birds.
No, there's nothing wrong with taking a break between undergrad and graduate school. Don't feel like you have to go straight through. But I would say continue with this research as much as you can. It sounds like you've already had the opportunity to present these findings. Are you going to be writing this up as like a thesis, or as like maybe a potential opportunity to maybe get something submitted to an undergraduate research journal?
I think that would be nice. That is something I would like to do, but of course I can't really know for sure what the future holds, but I definitely will try to like to go that route where I can like keep focusing on this subject and even go further with it and try to get more like work on my research papers and get something published and just keep going even further with that.
Yeah, Dr. Bednarz is an excellent faculty mentor, so speak with him about that. I think, even if you decide to take that break between undergrad and grad school, I think what we're all realizing at this point is that grad school is probably going to be the next step for most people. You're going to need some form of education past the bachelor's degree in order to be competitive, whether it's going on and being a faculty member or researcher, or just finding employment. And so work with Dr. Bednarz, and I think there's lots of different avenues to get this information out there. And if you're able to apply to graduate school and already have a publication that you've already done undergraduate research, I think that those are things that are just super helpful in kind of helping to get your application, in front of a committee of faculty who are making these decisions. So excellent work. And how about you, Drew? What about you?
Yeah, thanks for the question. I probably won't immediately continue with birds. I have done a lot of undergraduate research in the Hoying House and Roberts laboratories as well. Both those labs work with fish. And I have accepted a research assistantship at the University of Alaska Fairbanks, where I'll get my master's degree studying the toxicity of copper to sockeye salmon in the Bristol Bay watershed starting next fall.
Awesome. My old roommate from college from my undergrad actually did his PhD at Fairbanks. So
Awesome.
He's a environmental cultural geography is his area. So I think they were studying like the receding ice shelves, I believe.
Oh yeah.
So yeah, he was up there on a NSF graduate assistantship. So he really enjoyed his time in Alaska. So congratulations.
Hey, thank you.
Are you going to live near campus, or are you going to live in like a cabin in the woods somewhere?
I'm looking at dry cabins, hopefully within a few miles. I do have a 4-wheel drive vehicle, so I'll be able to hoof it a little bit. But.
That's awesome. Congratulations, Drew. That's amazing.
Hey, thank you.
That's all I had for today. Any other questions or anything, any follow-ups that anybody has? Oh, all right, Kylie. What do you got, Kylie?
So I had one question for Monica. I thought it was really interesting that you had significant results in your interspecies comparison. And so I was wondering what you think accounts for that interspecies comparison, if it is causal.
Oh, I'm sorry. It's not working now. There you go. Sorry about that, Monica.
All right, thank you. I know that if I remember correctly, I haven't bird-banded in a while, but I'm pretty sure indigo buntings are smaller than swings and thrushes. I remember like when I would hold them and like, band them and stuff, I'm pretty sure the swings and thrushes were more of a handful. So they are bigger birds, which kind of makes it more surprising that they would be caught more in the far space nets, because far space trammels tend to have shallower pockets. So you would think a bigger bird in a shallow pocket wouldn't mix well, but it also might be that the pockets were still not significant, so sufficient enough to keep them in there. Plus, when trammels are further apart from each other, there's a larger surface area of the nest. So maybe they fly either kind of like higher up in the nest, since trammel spacing was always approximately 30 centimeters from the bottom. There's mostly a difference in like the top of the trammels, like how far that would go up. So it's possible that swings and thrushes fly higher than indigo buntings and tend to get caught higher up in the nest. Also, indigo buntings, let me see if I have more in the near space nets. I'm not sure. They're also like, another idea I have is with, I think what Drew said in terms of the visibility, there might even be differences with how well they can see the net, like how fast they fly, if they tend to stay closer to the net so they already know they're there, or if they're kind of flying from further away and they just happen to run into it. So there's a lot of things that could be going on there with why those differences exist. I would definitely be interested in maybe in the future doing more research into that and looking more into the species patterns that exist, because I would also like to know why that happens, because there's things that like don't make sense there and things that kind of make sense. And if I could explore more into that, I would like to, but I think mostly it's a matter of like probably where they're flying, like how high up, and also their size.
Again, thank you for being here today. I know it's not the most opportune thing to be doing this through Zoom. It's a lot more fun when it's in person, but I think that you all did a really good job. So congratulations. All right. Well, good luck with everything and be safe.